I think we're gone live. So hello to everyone watching and thank you for tuning in. I'm Rebecca, one of the co-organisers of the Biodiverse Festival, and I'll be hosting the talk for today. I have the most amazing job of introducing the wonderful Dr. Mika Tosca, who's here with us now. Just before I introduce her, I have to let you all know how everything's going to work. As with any online event, there is the possibility that we'll experience some technical difficulties or some kind of connection issues, but don't worry if this happens, we are recording the talk, so if there are any issues with the live stream, we will upload the talk to our YouTube channel later, so you don't need to worry about missing out. There should be time at the end of the talk for a short Q&A, so if you do have any questions that you'd like Mika to answer, then you can submit them via the Google form that is in the description below, or if you have a YouTube account and are happy for your name to appear next to your question, then you can comment directly in the YouTube live chat. We will be limited with time for questions, so I'm sorry if we don't get to address everyone's question, but hopefully there will be time for quite a few. All right, so now you know all of that, let's begin the introduction. So Mika is a trained climate scientist who completed her Ph.D. in 2012 at the University of California. It was there that she researched the interconnectivity of the climate system with landscape wildfires and their aerosol emissions. And she continued this work as a postdoc scholar at NASA's Jet Propulsion Laboratory in Pasadena. There she used multiple satellite sensors to research the interactions between climate, clouds and fires to understand the complex relationship between wildfire smoke and cloud formation as part of the NASA Oracle's field campaign. So from completing complex scientific studies to communicating complex science effectively, Mika has done it all. In 2017, she became an assistant professor at the School of the Art Institute of Chicago and is now investigating whether artists and designers can help scientists conduct and communicate climate science more effectively. And this will be the theme of today's talk, which is engaging non-scientists with science via art. I will now be turning my camera and audio off for the duration of Mika's presentation in the hope that it makes the live streaming a bit smoother. Obviously, I will still very much be present and listening, and I'll reappear at the end of Mika's presentation for the Q&A. So over to you, Mika. Thank you.
Thank you so much for the invitation. This is so exciting for me to present in this capacity to this audience. I apologize if I'm a little slow. It's 9 in the morning here, but I have had my coffee, so I think we should be good. So I will share my screen. And we will get going. So the title of my presentation is Reimagining Futures, Collaborations Between Artists, Designers, and Scientists as a Roadmap to Solving the Climate Crisis. So I, myself, as was noted in the introduction, am a climate scientist who has the incredible privilege of teaching science and climate change and environmental disasters and the like to art students at the School of the Art Institute of Chicago. And during my time at the School of the Art Institute of Chicago, I've been thinking about ways in which artists and scientists can collaborate not only to better communicate climate science, but also to better and more effectively conduct the investigation that is involved with doing science. And I want to start this presentation with a quote from Parable of the Sower, a sci-fi novel by Octavia Butler, which some of you may have read this summer because it finally reached the New York Times bestseller list 30 years after it was published. And this quote, I think, really drives some of the motivation for why I'm investigating the things that I'm investigating and why I do the work that I do. So I'll just read it. The world is full of painful stories. Sometimes it seems as though there aren't any other kind, and yet I found myself thinking how beautiful that glint of water was through the trees. So Octavia Butler and other contemporaries are what we like to call Afrofuturists, They have done a lot of thinking about future worlds and future world building. And so I use this quote to guide my research because, as I'll note throughout this talk and at the end especially, we're sort of at the end of one world, a world that's plagued by climate crisis and rising fascism in response to climate crisis potentially. And we have to build a new world, the world that comes after that. And I think in order to get us from this world to that world, we really need to utilize the diversity, not only in identity, but also in practice. And that's why I work with artists in particular on this effort. Before I get to that, though, I always give this presentation in person. I've never given this presentation virtually. And so normally I would have an audience and I would ask you all these questions, but unfortunately I cannot do that. And so I'm just gonna sort of go through this anyway, and you can think of the answers in your head. So I wanna address the issue or the question of what is nature, okay? It seems straightforward, but actually as we get into it, you'll notice that it's not as straightforward as maybe you thought. So the first question I wanna ask is, do you consider yourself a part of nature or separate from nature? I think most of you would respond that you are a part of nature. You are a living, breathing animal. You interact with the environment around you. We're part of Earth, therefore we are natural. Then I would ask you to list some words or things that you associate with the word natural. And you might say things like trees, grass, rocks, the sky, etc. And then I would ask you to list some words and things that you associate with the word unnatural. And you might say things like capitalism or concrete or plastic. And so this represents, I think, an important cognitive dissonance, or this points to an important cognitive dissonance where most people have a sort of visceral understanding that they are themselves a part of nature, but actually in a practical and material sense, we have very much separated ourselves from nature, because when asked to list words that are associated with the word unnatural, we always list things that are created by humans, plastic, for example. And so I think that this fundamental disconnect is really something that is driving the climate crisis, actually. Our separation from nature, our practical separation from nature, despite thinking that we're a part of nature, we have practically separated ourselves from nature. This practical separation from nature doesn't really allow us to fully address and arrive at solutions to the climate crisis. So we have, in fact, separated ourselves from nature, and we need to reimagine our future as one where humanity and nature can coexist, where we are a part of nature, fully integrated part of nature. And in doing so, we need to redefine the boundaries between what is natural and what is unnatural. Which brings me to the role of aesthetics. I'm a scientist who works at an art university, and so I think about aesthetics a lot, and my practice involves utilization of aesthetics. And so before I get to that, I want to show this poll which I found from the other day that was conducted by the Pew Research Center. And in it, you can see that it asks what the majority of how the majority of Americans see scientists, how Americans see scientists. And almost 90% of Americans see scientists as intelligent. That's great. Got something going for us. But unfortunately, only 54% of Americans see scientists as good communicators. This is a fundamental problem, right? At least we're viewed as smart, but we're not really viewed universally as good communicators. And so how are we expected to maybe convince is not the right word, how are we expected to bring the public along with us on a journey to arriving at solutions to the climate crisis if they see us as smart, but they don't see us as good communicators? In fact, 43% of Americans see scientists as socially awkward. So this is why perhaps we need to more fully embrace the role of aesthetics. And I'm reminded of this quote, which it seems that in the conversion from Keynote to PowerPoint, the author of this quote's name has been kind of grayed out, but it's David George Haskell's Notes on Ecological Aesthetics is the essay. And I'll just read this quote because it drives a lot of my thinking around this issue. Once we collectively have an integrated sense of aesthetics, we can begin to discern what is beautiful and what is broken about a place. And from there, I believe we can begin to form an objective or near objective foundation for ethical discernment. Answers emerge from the community of life itself, filtered through human experience and consciousness. The layman's term translation of this is basically the human imagination is drawn to aesthetics, is drawn to things that engage us on a creative, sort of more visceral level, okay? In a way that typically science has not been able to do, at least in modern science, right? In this 2020 version of science. And this is why I think we really need to lean more on aesthetics to help us get into the public consciousness in a way that we haven't been able to do before. And so I want to bring up this book by Timothy Morton called Hyperobject. So a hyperobject is an object which is so large, so vast, perhaps temporally and spatially large, that it's difficult to really grasp what exactly it is. What is the material reality of the object that we're talking about? And so we call that object a hyperobject. And Timothy Morton defines climate change as a hyperobject, an abstracted object that is so vast in scope that it's difficult to grasp exactly what it is. And so while we all encounter abstractions in our work, scientists and others, artists and designers in particular intelligently address abstraction and create objects every day. All art is an abstraction of reality. And so it makes sense then, to me anyway, that climate change, being a hyperobject, would be a subject that artists and designers could very intelligently take on in a way that scientists have not been able to do. And so, of course, me being a professor at an art school, I want to share with you some of the ways in which my students, artists, all artists, have done this, have taken on climate change as a hyperobject and communicated it through aesthetic rendering. And so I'm just going to show you some examples from my students. So my sort of flagship class, if you want to call it that, Earth's Changing Climate, deals with climate change, both past and future and present on Earth. And for their final project, I asked my students to do research on a climate change sort of problem or projection, and then to write an essay about it, and then also to create an artistic artifact, a work of art, if you will. And so I'll start with this one, which is called Climate Deniers on Vacation by Katie Wittenberg. It's a print. It's a fun print to look at. The colors, the composition of it is really fun, but it also contains some really interesting information. For example, you can see the characters depicted are all very notorious climate deniers. You can see the Koch brothers. You can see Scott Pruitt. You can see Rex Tillerson, the former CEO of Exxon, sitting on these polar bears, which are an enigmatic species, a charismatic species that have come to sort of represent climate change. And then in the background, you can see a mountain range that has been rendered, which is actually an abstract depiction of the temperature record on Earth. You can see it going up from left to right. And so this is conveying a lot of information in a very aesthetic way. Here's another example, the not so great waves. So this is linking back to the Great Wave print, the silver print. It's been inverted, it's been reversed, okay? And my student Noah threw some trash in the middle of this wave to sort of represent the impact that humans have had on nature, on our natural environment in the Anthropocene. This print also, which is hanging in my house, by the way, this print also is done in a was created in a way which is referred to as suicide printing. And so what it is you carve out some of the, what you ultimately want to depict. You put the ink on, you print it, and then you carve out more and you put the new color ink on top of it. So you only get one chance to print each color ink. So if you mess up, there's no going back, which is kind of like climate change, right? It's a kind of an analogy or a metaphor for climate change. Here are some more examples. On the left, we have a climate change quilt by my student Mika, and they're showing here the intersection of climate change and natural disaster with other things in our world which play with or interact with some of these man-made crises, right? So we have gender identity and class and race and geographical location and loss of resources, denial of aid, access to resources. This has all been compiled and composed in a single quilt to serve as a metaphor or an analogy to the greenhouse effect, right? Which we talk about in class as being sort of like putting a blanket over the earth. So putting a quilt over the earth is sort of an aesthetic representation of the greenhouse effect. On the right, we have a picture of an artifact that one of my students made. It's actually a plastic water bottle, the shape of a Nestle plastic water bottle made from glass. And around the top of that water bottle is a koozie, which is actually made from the original plastic water bottle that was used as the mold for the glass water bottle. And so this is obviously playing with lots of themes that are inherent to the Anthropocene and the climate crisis, namely our obsession with and the ubiquity of plastics and the unnecessarity, that's not a word, the how unnecessary plastics are. And of course, the bottle itself is made from glass. Here are some more examples. On the left is a screenshot of a global warming Snapchat rant. I know a lot of folks, especially sort of Gen Z and younger millennial folks, use Snapchat with their friends and with others. And so my student Mandy created a whole 20 or 25 snap series rant on global warming, what it is, why it's important, why we should be paying attention to it, which is really fun to watch and flip through. And then on the right is one of my favorite projects that one of my students have done. It's called Cake for Birds and Mothers. So we have an endangered species of bird that nests along the Lake Michigan shoreline in Chicago, which is very endangered at this point. Because of climate change, the lake levels have been rising and falling, and also because of the encroachment of the urban landscape and the suburban landscape. And so many efforts have been made to protect this species. And so my student made a cake, kind of to say thank you, a love letter to this endangered species. And she did research on the types of seeds and the diet of these birds. And she left the cake out all day for the birds to eat. And she wrote some prose, some poetry, and filmed it. And it's actually, I don't have time to play it, but if you're really interested in this, I can send you the link. It's really wonderful to watch. Here's another example that one of my students made. Ethan, who is from the Midwest, and one of the sort of impacts of climate change is that severe weather in the Midwest is likely to get worse. Perhaps tornadic activity will increase or get more severe. And so this is a poem that Ethan wrote. Half of it was written in ink that only shows up under a black light. And so the idea here is that as severe weather increases, one of the results or impacts of a severe storm moving through your town is possibly the loss of electricity. And so the only way that you can actually read this poem about severe weather is using a blacklight flashlight. Here are two more examples. On the left, we have negative images. This is a coral. These are images of a coral reef that have been corrupted. The JPEGs themselves have been corrupted. What's cool about this is that this image was made by my student Abigail McDuff in collaboration with her 7th grade class that she was interning and shadowing for. And actually the 7th graders showed her how to corrupt the JPEGs. Obviously this has sort of literal implications for the worldwide loss of coral reefs that we're now observing due to the climate crisis. On the right, this is a cartoon of Venice called Venice's Flooding and the Human Allure, and you can see that it's a really sort of aesthetic, beautiful rendering depicting something that's ongoing due to climate change, sea level rise, of course, right, which is slowly sinking the city of Venice, and also Anthropocene activities, which are physically sinking the land on which Venice sits. So this is also hanging in my apartment. So this brings me to sort of my main hypothesis of all of this work, which is looking at ways in which, as I mentioned in the beginning, artists and scientists can collaborate not only on better communication of climate change, which is perhaps shown in some of the aesthetic examples that I've already given, but also ways in which artists can help scientists, and vice versa, conduct scientific inquiry more effectively. And so I want to introduce something which sometimes is controversial, sometimes gets people thinking. I'm really interested in feedback on this. We're looking to publish this at some point in the next year. The journal is TBD. Not a lot of journals specifically are geared towards the intersection of art, design, and science. But either way, here we go. So the scientific method, which is depicted here, I know it's not a linear process as depicted. It's very circular. But to keep this simple, to simplify this, basically the scientific method begins with a hypothesis, moves to a sort of an experimental phase, right? And then ends and results with a conclusion or a theory. Okay, so we have hypothesis where you question, you propose, you imagine, and you explore the problem, an experiment where you're measuring and analyzing the problem, and then a conclusion where you're publishing your work and you're discussing it and you're presenting it to other people. The design and art making processes are similar to the scientific method. You have an ideation phase, which kind of corresponds or is an analogy to the hypothesis phase. You have a prototyping phase where you're testing, you're observing, you're proposing changes for your final artifact. And then you have a refinement phase where you polish, you implement, and then you deliver a product, whether it be a work of art or a materially designed artifact or a website or whatever. The difference between these two processes, I think, is the first step in the design or art making process, which is a human-centered understanding phase, empathizing, learning, listening, talking to people who are going to engage with or use the artifact that you're creating, right? I think this is something that scientists don't often do or don't often prioritize, that artists and designers do in fact prioritize heavily. This understanding phase is a really important part of the design process, which means that the design process, to me as a scientist, is much more human-centered than the scientific method. And so I want to share with you some results of some design work, some hybrid design and scientific work that I did with some designers at the Jet Propulsion Lab a couple of summers ago, and where we're going with that research and how it informs this hypothesis that I have. So the motivation for that work, which I'm calling sort of redesigning science, comes from my previous work that I did for a decade before coming to SAIC, before coming to the School of the Art Institute of Chicago, and specifically a research trip that I took to Africa in 2016, to Southern Africa. I went to Namibia and South Africa as part of the NASA Oracles field campaign. And while I was in Namibia, we were looking at the impact of smoke aerosols from fires on clouds, and I had the opportunity to travel to Zambia briefly, where I talked with some folks who engaged directly with the burning, with the fire burning that happens in Africa every summer in the south and every winter in the north. And I'm still struck by this quote from Chris Kayanesha, and this is a paraphrase, but in general, he said, "In 41 years, I never left Zambia, but these farms now are so dry this time of year, it doesn't rain anymore. We used to have rain in October and September. Now it's November. I don't know why, but we need water. It's so dry. I guess it's global warming, but we need water in Lake Kariba or we won't survive." So in the global north, we often have language to talk about global warming. We have these scientific papers which are published very frequently in major journals which talk about global warming, but we very, very often forget to engage with and talk to folks who are on the front lines of a lot of these changes that are occurring because of the climate crisis, right? And so there is a fundamental disconnect between the science that people are doing and the communication of that science that people are doing. And sometimes I think that's because the science that we're doing hasn't involved this human engagement component that the design process has. And so I'm going to obviously be talking about a project that I did at JPL involving wildfire. My previous research before embarking on this art and science collaboration dealt with looking at the ways in which smoke from wildfires interacts with solar radiation and cloud formation and others. And so I can't begin a discussion about wildfire without showing you an aesthetic rendering that one of my students made, a print of the wildfires in California. This was two semesters ago. This map here shows where all of the fires that occur on the Earth that are caused by humans, anthropogenic fire landscapes, from a paper by Sally Archibald, which was published in 2017. You can see all the blue dots represent fires that were observed on the Earth that have been attributed to anthropogenic influences. Okay, so obviously fire landscape is very heavily driven by human activity. And we noticed the past few years with the increase in burning in the Amazon, for example, which has been going on for many decades, but seemed to have an uptick this year, probably due to a number of geopolitical factors. And so in my time at JPL, working with a team for a satellite known as the Multi-Angle Imaging Spectroradiometer, the MISR satellite, which is a spectroradiometer. It sees from space, just like any other sort of visibly reflective satellite would see the surface of the Earth and the atmosphere above it. But what's really unique about MISR is that it has multiple camera angles, and so we can actually see almost the three-dimensional rendering of things in the atmosphere. And so what we can do is we can use MISR and a software that I had a part in developing and using at JPL. We can see how high in the atmosphere smoke from wildfires goes, right? So you have a wildfire burning, the smoke goes up into the atmosphere. We can use MISR to detect how high, what the altitude of that smoke plume is. This has important implications for climate, of course, right? As it's transported and then ultimately deposited across the globe, knowing where in the atmosphere that smoke is going can improve the representation of fires in climate models, which we can then use to project future effects. And so with undergraduates for several summers in a row at JPL, we compiled a global database of all of the plumes from fires that we could see on the globe in any given year. And we have now, I think, 5 years worth of data, 5 continuous years worth of data from 2008 through 2013 at this point. And so what we've done is we've used the MISR, and every plume that we can see, right? Every plume that MISR saw, we can use this software to calculate how high in the atmosphere that plume has gone. And we now have a database of thousands and thousands of plumes. And here is where those plumes are located. This is the website where those plumes are located. Now, I think it's safe to say that this website is bad. It's not good. It doesn't look good. It's very difficult to understand and engage with. As a scientist, I'm already confused. How do I get the plumes? Where are the plumes? I can't see anything about the plumes that are in this database. And I have this Mercator projected map, which isn't even what the world looks like. And it's divided into these regions, which make no sense to me. And so this website is sort of a mess. And so what I did is I wrote with a few colleagues from JPL. We wrote a grant to work with designers to redesign this website with the goal of not only making it prettier and more aesthetic, but also potentially making it easier to use, which would, by proxy, then result in possibly better science being done, right? If we can make the website better, and better is a subjective term, perhaps we can make the science that results from it better. Because what was happening is that I created this data set. I helped create this data set, this multi-year data set that I thought was very valuable, that nobody was using. And probably nobody was using it because the website and the way in which the data are delivered is cumbersome, is abstruse, is difficult to understand and work with. So we hired a design team, we worked with the design team, and I got firsthand insight into the design process. And so the first step of that design process is the contextual inquiry, the human-centered engagement, understanding the people and the problem. So contextual inquiry is a design technique in which people are studied in their context of action in order to build a clear understanding of what they do and need. Lots and lots of collaboration, multiple interview sessions, discussions, workflow demonstrations. There's an emphasis in the design-making process about engaging with humans. What do humans want? What do people want? How are they going to use this product? Is it going to serve what they need? Serve them in the ways that they need to be served. And I want to show this because I just think, so I should mention also, sorry, going back a little bit here, I don't have it. This work was done in collaboration with a brilliant designer, Adrian Galvin, who, after this project, ultimately defended his master's in design thesis and now is full-time designer at the Jet Propulsion Lab. So this is a picture of Adrian's notes during this human inquiry, contextual inquiry, human engagement, part of the design making process. And I just like to show it because I do think Adrian is a brilliant illustrator. So once we've had this initial sort of engagement with humans, understanding the people and the problem, there's some ideation sketching, which is very similar, I think, analogous to the scientific method hypothesis step, where you draw interfaces, sketch ideas. Sketching is a low cost and intuitive way to iterate on these ideas and create artifacts that the team can respond to and have helpful conversations around. So again, emphasis is on human engagement. Here's an example of one of Adrian's first ideation sketches. Then there's more collaboration. So here's a picture of myself collaborating with one of the designers on the project, where there's lots of conversation and co-designing with scientists, showing sketches, sharing ideas, which is allowing the climate scientists, who are ultimately the people, the users that are going to be working with this new website, to give us ideas, clearer ideas of what we needed, what we could use, what would be effective for our scientific process. And so when creating these sorts of novel visualizations, it's difficult to imagine what it might show. And only by working in close collaboration can we ensure that the designers were on the right track, right? It's that human engagement that's really necessary here. So then there are some paper prototyping and some more testing, and then a digital prototyping of what the new website is going to look like, another paper prototype, and then another testing session, and then another digital prototype, and then finally we get to the results of this effort. So I want to return back to this initial image of what the website looked like before the redesign, right? Before we threw this out and started from scratch. Very difficult to use, very underused data set, probably because the website is so difficult to interact with and engage with, right? Science is about thinking through hypotheses and investigating problems. And scientists don't want to be burdened with understanding how to download data, where the data are, what data are available, and why they should use those data. So here's what the new website looks like. And of course, this is a beautiful artistic rendering, with a nice computer, but the home screen looks like this image here. And you can see there's so much information that's conveyed just by like opening the new URL to the website. We can see where those fire plumes are, and in this image, the height of the bars indicates how many fire plumes are in each gridded region, right, in each bin. I have all sorts of controls which allow me to subset by temporally, by spatially defined parameters, and also I can look at XY plots now with a very easy click of a button on the main website page, so I can compare right away of all the plumes in the database, relationship between the max plume height and the total fire rate of power, for example, for different filters, which can represent different regions, different biomes, different subsets of biomes. I can create pie charts of where the plumes are located. So for example, in this subset, 42% of the plumes, 42.8% of the plumes are located in Africa. I can even look at maps. The size of the dots in these maps can represent the strength of the plume, of the fire rate of power, for example, or the height of the plume, for example. So all of this is done through the website. I don't even have to do anything. I just click through and play with the filters. I can also filter by biome, and I can color code it by biome. And I can zoom in and out, and my bins adjust in size so that I can really see what's going on. The closer I get, the smaller in relative ratio the grid sizes become, right? And so I get a very clear picture of where the fire plumes are located, perhaps how high the fire plumes are located. And so I don't have to do all of this initial sort of deciphering of the data. that I had to do before on the old website, which told me nothing when I logged on, except here are data, good luck, right? Now I can log on and I can see everything very, very clearly, where it is, what it's doing. And because of this, I can now do better science. So with Adrian Galvin, we did a controlled environment study where we worked with some users of these data sets, of these data, and we showed the user the new URL, the new website, and Adrian just observed what happened as they clicked around and played with the interface. And so we noticed that, and this work is still ongoing, this is the work that we're hoping to publish at some point later this year or next year. We noticed that scientists were asking more questions, and we were sort of identifying when scientists who were using this new website came up with new hypotheses. And you can see that even just in the short time of about an hour, there were 1, 2, 3, 4, 5, 6, maybe 7 different hypotheses that the scientists drew just from playing with this new website. The old website, it may have taken an hour just to figure out where the data are and what data I should download, right? And so there has definitely, in our opinion, been an improvement in the way in which science is conducted when you can engage with something that appeals aesthetically to our brains, right? And so at the end of a 51-minute session, this particular scientist was able to sort of arrive at a complete paper topic and then begin the actual work that we sort of normally would attribute to the scientific process. And so I'm hoping to expand on this research and continue to think about ways in which art and design not only communicate climate change better, because I think that that's something that we all understand, that aesthetics and visual or audible or sonic representations of these sort of vexing concepts and problems is one thing that art and design is really good at. But art and design, I argue, is also really good at helping scientists do better science, helping us all arrive at better conclusions, more conclusions, and ultimately more effective sort of results and messaging. So before I end, I want to return back to the ideas and the concepts that I began with, specifically the Octavia Butler quote from Parable of the Sower, thinking about world building and future worlds. So I like to offer a bit of optimism, especially to my students who are often bogged down by this material. In our class, it becomes very sort of depressing at times. And so I like to offer a bit of hope, a bit of optimism. This isn't the end of the world, okay? It's not the end of the world. It's just the end of this world that we've created, this world of climate crisis, this world of anthropogenic and environmental destruction, right? So we now are presented with a radical and revolutionary opportunity to make the next world that we build, a better, brighter, more equitable one. But if we don't first imagine the future world that we want, okay, we will never have the future world that we deserve. And how can we possibly imagine this future world if we don't incorporate diverse voices, which includes artists? Okay, so in order to capture the human imagination, we need artists. We need to have these, what I like to call radically interdisciplinary collaborations between artists, designers, scientists. That's what's going to capture the human imagination and get us to the next world. So with that, I will say thank you so much again for listening and for the invitation, and I will now take questions, I guess.
Thank you. That was so fascinating, and we have received a few questions. So there's one in the live chat that says, sounds great. How did you decide what display features or plotting tools to use? And I think this is relating to the Plumes NASA website.
Yeah, that's a great question. So as the scientist and not the designer, a lot of those decisions were left to the designers. But again, as I emphasized in the talk, done in close collaboration with scientists. So Adrian would work with his design team, create something, and then come to us and say, you know, here's what we've got. What do you think? And we used it, we interacted with it, and we identified maybe this feature is not necessary. this feature is necessary. And so all of the individual features were sort of collaboratively decided on by our team of scientists and designers. This is important, this is not important. For example, we all identified that binning by biome would be really important because fires are different if they're in a tropical rainforest versus a savanna, for example. And that binning by region wasn't so important. So we emphasized the biomes and we de-emphasized the region, but the old website had really a high emphasis on the region, which doesn't make a lot of sense when you're thinking about fire necessarily. So we were really interested in including that biome sort of binning feature, which the original website didn't even kind of consider before.
That's so cool.
Yeah.
Awesome. We've had another question which says, do you have any thoughts on the faux sustainable aesthetics? I think this is relating to greenwashing.
I do have a lot of thoughts on the faux sustainable aesthetics. I talk with my students a lot about this. So I teach, one of my courses that I teach in the spring semester is called geoengineering. And maybe some of you have heard about geoengineering. It's controversial. I don't necessarily agree with it, but I like to teach it because I like to teach controversies. I like to have controversial topics in my classes. And in my class in the spring, I actually had a great number of architects who were in that class. And we talked a lot about this, that a lot of infrastructure that's sort of designed today includes these sustainable features, but how effective really are they? And one thing that we talk about a lot is white roofs or reflective roofing. And the the research shows that white roofs are not the most effective way of, if you're thinking about doing some sort of geoengineering, white roofing is not necessarily the most effective thing to do, but it's something that, designers do a lot to kind of slip in to their design, like, oh, this is going to be sustainable, right? Another really good example is the planting of trees. So people are always like, oh, let's just plant trees to take out carbon, right? That's a geoengineering technique as well. But it depends where you plant the trees. It depends. If you plant those trees in a desert region, you actually might be making things worse because the trees are darker than the sand or light colored surface below them, right? And so they'll absorb more solar radiation, and then that'll ultimately increase climate change. So it depends where you plant the trees. So a lot of these things are not well-researched aesthetic solutions. So aesthetics are not always going to be sort of the right path. You have to really consider what it is you're doing and why you're doing it. So it needs to be well-researched. So something I learned about, something that sort of I came upon as a scientist teaching at an art school is that artists actually do a lot of research. Artists and designers do a lot of research on these things. And one way I think in which this collaboration can benefit both of us is that scientists can draw on these aesthetics that artists and designers utilize, and artists and designers can learn a bit from the way in which scientists conduct research. And so then we can arrive at sort of a better result. I hope that answers.
Yes, definitely. I think you've frozen. Oh, okay, no, you're back. Awesome, cool. A question which is kind of related to the greenwashing one is, do you think communication using art and design can combat climate apathy?
I do. I think it's a complicated answer to that. I think so. I think climate apathy is definitely a problem, and I think, as I argued in my talk, and I argue often in my work and on Twitter and where anyone who will listen to me, that in order to get people on board with solutions, with actual solutions to the climate change, you've got to meet people where they are. And I think one way that we can do that is through capturing their imagination. I think humans, we have these brilliant and vibrant imaginations, and science is typically, in this way, sort of modern rendering of science hasn't really gotten very good at that. I think that we've drifted away. modern capitalism has sort of siloed all of these disciplines. So science is over here and art's over here. And if you talk to each other, it's like hearsay, and it's very like, we're off in our own worlds, and we don't think about capturing human imagination. And so I do think that art especially can be a way of capturing that imagination, of thinking through these questions about future world building, right? Like I said at the end of my talk, if we don't imagine the future first, then we're not going to have it. So we've got to imagine it first. And I just personally, as a scientist, I think I can say this, I don't know that scientists are great at capturing the imagination of the general public in a way that it needs to be captured. And so I do think there are many ways. Now, I think sometimes when I present this material, people immediately think of art as like high fine art in a museum. That's not necessarily the type of art that I'm not always talking about. There's some value for that, of course. People love going to museums, but there's also art like the project that my student made where she left a cake out for the birds to eat, right? There's ways in which participatory art or procedural art, right, can be done that can engage people in ways that can capture their imagination, right? Like a trash cleanup. One of my students for their project did like a trash cleanup of Grant Park on downtown Chicago in Lake Michigan, right? So it's like art and also sort of this practical thing that we can do. So art doesn't always mean fine art in like the Louvre. It can mean a lot more than that. And so I do think that art and design and aesthetics can capture the imagination, and we've got to capture that imagination of people if we're going to get anywhere. Yeah.
Thank you. There's a question that's kind of related to what you just touched upon, in that scientists aren't thought of as being creative, but science needs a surprising amount of creativity. Do you think this stereotype is harmful to science, almost a self-fulfilling prophecy?
Absolutely. That's a really, really great question, and that drives a lot of this. And I think it was like an early slide in my presentation, when I'm talking about climate change as a hyperobject, we're all creatively interpreting things that we see, abstract things that we see, rendering them, right, as an abstraction that we're hoping people understand and latch onto and then can make conclusions about. So everyone is doing this work, absolutely. Everyone is doing this abstraction, this creative thinking about problems. But I absolutely agree with whoever asked this question, brilliant question, that I do think the stereotype of scientists not being creative hurts science. And this is precisely why I do think art and design are necessary. Because working at JPL, the Jet Propulsion Lab in Pasadena, when I moved to the Art Institute, when I moved to Chicago, I still was working over the summer with some folks from Jet Propulsion Lab, and I would have lunch with them and I would talk to them, and they would always sort of, the way in which they talked about art was this weird sort of like almost disdain, or like it was a world separate from theirs, like, oh, artists are just doing this like floofy, like sort of art that's like not real science, or it's not like a serious discipline, right? And I think that the question gets at this perfectly, is that scientists, we've all been to scientific talks where it's so esoteric and the graphs make no sense, and we're just like, my brain shuts down after 10 minutes. I don't want to watch. I'm no longer invested in the results or the conclusions of that study. And so I do think there is like an important element of creativity in science, and I just firmly believe that one way to get us back to that is to involve artists in the process of scientific endeavor, because art itself is a science, right? I very strongly subscribe to the sort of idea that it's not STEM, it's actually STEAM, right? STEAM, where the A stands for art. I think the art and science are much more closely related than we like to think as scientists. Yeah, awesome. Great question. Wow. Whoever asked that question, I would love to talk to that person.
Unfortunately, I think it was anonymous, but maybe they'll pop up in the live chat now.
Yeah.
The next one says, historically, science is presented in journals and at conferences, and art is displayed in galleries. Do you think these old models need repurposing to create space for work that transcends or that transcends the confines of art and science? Or do we need to create an entirely new medium?
Honestly, maybe we do need to create an entirely new medium, actually. This is something that I know the art world in particular. So being a scientist and moving to the Art Institute of Chicago, I had to learn kind of two languages, I like to say. I know the science language and I know the art language. And then when I give presentations like this, I'm often conflicted on what language I'm supposed to use. And so I've created a new language, which is an art science language. And not many people speak that language, I think. It's kind of, it's still in development, perhaps. And so I do think there's a lot of conversation in the art world about how galleries are an old model. And I think that there's now beginning to be a lot of conversation in the science world about how, you know, the way in which we have these peer-reviewed manuscripts and these journals is kind of an older model of doing things. Not to say that it's not effective or it's not useful, but like, you know, how many of us have published an article and we check that Google Scholar every day and it's got like 15 citations and it was published 6 years ago, right? So it's like, maybe we do need a new model of communicating or you know, codifying and presenting the research that we've done, which often is really important research, but hasn't been thought through the presentation phase of it, right? It hasn't been sort of modeled past, okay, you did the analysis and you made these graphs and you wrote a paper, but who's looking at it? Is it useful? Like what's, you know, and I'm not saying that all science needs to be useful, just like all art is not useful, but I do agree that, especially with the climate crisis, which is something that we need to solve 10 years ago, maybe we do need a new model for this, a new way in which artists and scientists can work together to create something that's gonna be more effective. You know, I always like to sort of think about this as I like to call it a radically interdisciplinary collaboration, where it's not just involving, you know, I think a lot of scientists think like, oh yeah, we do need art, and so they'll do their research and then at the end they'll be like, can some artist help me like make a prettier graph? And I think in speaking with a lot of artists are like, no, I want to be involved from the beginning, because like the stuff you're giving me to make this graph, maybe it could have actually just been better from the start. And that's kind of what I'm getting at with this work, that even embarking on a scientific inquiry, that process can be made more robust and more effective if there's like intense collaboration with a creative person, with a designer, with a maker, as we call them at the Art Institute.
Cool. Another question says, do non-visual / literary artistic creative processes have as much potential as visual art to help science be done better?
Yes, I do think, I absolutely do think so. One thing that I was going to show is, or one thing that I was going to include in my talk, but it's like maybe it would have been gone over a little bit too much, is one of my students actually created a sonic work, so sound, taking Jimi Hendrix's rendition of the national anthem from the 1969 Woodstock. And it's already kind of a dysphonic, you know, sounding song. If any of you have heard Jimi Hendrix at the 1969 Woodstock, you'll listen and it's like, you can kind of hear the Star Spangled Banner in it, but then also it's like, becomes very dysphonic and, you know, typical Jimi Hendrix. But my student, on top of that, imposed a sinusoidal interpretation of the song, which corresponds to the concentration of carbon dioxide in the atmosphere. And so it's taking this national anthem, which of course has, you know, metaphorical meaning to climate change and the role of the United States in not solving that crisis, and then applying onto it this carbon dioxide record, which makes the whole thing sound dystopic, really. It makes it, by the end, right, so it's growing and growing, and every year it grows. By the end, it's almost impossible to listen to, And so this is, in my opinion, sort of a really important way of thinking about this record in not a visual way, but in a sonic way. I'm hearing it. I'm hearing how bad it is instead of seeing how bad it is. And I think that sometimes, you know, people are auditory learners. They they interpret information much more effectively when they're hearing it rather than when they're seeing it. And so I do think there is a role for both. I mean, I'm here talking. I made a presentation where I had both visuals and I'm talking. So in a way, I'm embodying that. We all embody that when we present things. And so absolutely, to answer the question, like absolutely, there are non-visual ways in which this same hypothesis holds, with these same tenets hold. Yeah.
Thank you. Okay, I think there's still time for a couple more questions. So there's one that says, do you think there is good understanding of climate change amongst the design community, and what can be done to increase this?
So what can be done to increase it is collaboration with scientists. I do think so there is a good understanding. Actually, there's a better understanding than I think maybe some scientists are led to believe. In teaching my students, who are all artists and designers, they are very engaged with the material. They're very interested. They know a lot about climate change. They know a lot about it, but they maybe don't have the specifics, or they haven't put all the pieces together. And so that's my role as an instructor, but it also can be our role as scientists, right? That graph I showed at the beginning, that chart I showed at the beginning of the poll results from Pew, which showed that 54% of Americans, only 54% of Americans think scientists are good communicators, which means that 46% of Americans think we're bad communicators. That shows that there's a lot of disconnect here, right? That some of the fault with perhaps why the art and design community doesn't know as much, or isn't as well versed in climate change, is actually our fault as scientists in not properly conveying this information. And maybe it's just that we don't have the tools to properly convey it. And so we actually need this collaboration with artists. So this is why it can't just be done like in our separate wings of the academy. We actually have to meet together. And so going back to that question from a couple questions ago, maybe we do need a whole new discipline or medium, or something to properly do this, because I do think there's learning that can be done on both ends of this spectrum, from both, again, wings of the academy.
Awesome. Okay, I think we've got time for the last question, which is from Peter Nolan, and says, any tips for a scientist trying to enter working in the art/design world?
Get a job teaching science at an art school. No, I'm just kidding. Yeah, that's a really hard question, honestly. That is the question. I think probably the best thing that you can do is step outside of your comfort zone a little bit. Go to an art gallery. Go email an artist. There are lots of artists. Google on Twitter. There are lots of artists that are working at the intersection of climate and environment and art. And I think just having conversations, seeing where that goes, seeing where those conversations go. That's what I do that because it's sort of part of my job, right? So I'm privileged in that way, in that I can talk to artists every day. And so I've learned a lot just from talking to artists. And so I think talking to artists is so important. The second thing is that we need to prioritize this through funding, through money, right? Organizations, the government, whoever's got the money, start funding these collaborative projects, right? That's so important, I think, for this. And so there's not a lot of grants to apply for right now, but there could be if we start to prioritize these types of projects. I do think we're getting there. We're slowly getting to a place where we're prioritizing funding this type of work versus, the old models. And so I think talking and listening, and also like improving access through funding. Money is really, unfortunately, something that's necessary here. Yeah.
Excellent. Oh, well, thank you so much. That was incredibly fascinating. And yeah, it was wonderful to hear you speak. I just need to say, if anyone is interested in listening to tomorrow's talk, tune in at the same time. We'll be listening to Sheena Tolmer, a marine scientist who will recount the tales of 2 expeditions above and below water to generate new knowledge on plastic pollution. But thank you, Mika, for your talk on engaging non-scientists with science and engaging scientists with non-science also. It was amazing. Thank you so much.
Thank you. Thank you for having me. Thanks so much.